Hello Year 9, this is a video about energy resources. I hope everyone is doing very well at home and you're doing lots of independent learning. So, let's dive right in. First little job, I've got a little starter. We have 4 pictures and I want you to tell me, I want you to think about, what's the odd one out? Which one of these doesn't fit the pattern? Okay, we've got a little bit of a hint. Think about the energy source for each picture. Maybe think about the energy transfer. There's more than one answer. Okay, so maybe pause the video, have a think, maybe jot down an answer, jot down a letter, A, B, C or D. And think about the reason why. Why have you chosen B? Why have you chosen C? Why have you chosen D? Why did you choose A? Okay. Okay, so there's lots of different ways you can approach this and this odd one out picture. Okay, lots of different ways. C, the obvious answer, C is the odd one out because it's an example of electricity generation that uses a non-renewable energy source. Okay, C, picture of a coal plant or a fossil fuel plant, uses non-renewables. Okay, something that you can only use once, and once it's used up, it's gone forever. Okay, A, B and D are examples of electricity generation that uses a renewable energy source. So the other 3 letters, A, B and D, wind, water and sun, they are renewable sources. So both of these answers are good, perfectly valid. Okay, that's your odd one out. These are the ones that links together and the reason why. But you could also choose D. D is the odd one out since it transfers light energy to electrical energy directly. Okay, D could be a photovoltaic cell, PV cell, like you have in your calculator. Whereas A, B and C, they transfer kinetic energy to electrical energy. Okay. With the wind, we have this kinetic energy driving a turbine. With coal, we'll heat up some water, changes into steam. That steam has kinetic energy. We use that to drive the turbine blades. With B, hydroelectric power, we let water flow through pipes. It will have lots of kinetic energy. That is transferred to a turbine blade which spins, connected to a generator. That is where the energy transfer changes that kinetic energy into electrical energy. But D, we directly go from light energy into the photovoltaic cells which generates electricity. Okay, now I'd like you to pause the video and I'd like you to write down a list, so you can just jot it in rough or you can do it neatly, it's up to you, of different energy resources that are renewable and different ones that are non-renewable. Okay, so just write down the things that you know already, which is non-renewable, which is renewable. Okay, here I've got some extra energy resources. See which ones you have, see which ones you've missed. Okay, put them in the correct place. So, biofuel. Biofuel is a renewable resource. Wind is a renewable resource. Water, renewable resource. Geothermal, renewable resource. Tidal, renewable resource. Solar, renewable resource. Waves, renewable resource. Nuclear, non-renewable. Coal, non-renewable. Oil, non-renewable. Gas, non-renewable. Most of the resources that you need to know about are renewable resources. Okay, they can be replenished, they can be replaced as soon as they're used. Okay, non-renewable resources will eventually run out. They're not being replaced at the same rate that we're using them. Okay, now, not only do you need to know which of these are non-renewable and which are renewable, you also need to know a little bit of information about them all. Okay, so here's a nice little picture of my different resources. So we can start at any one of these points, okay, and I'd like you to write down a fact, okay, if you know one, about any of these resources. Just one fact. Okay, now if you want, you can do this at the middle of a piece of A3 paper, or do it quite small on a piece of A4 paper on a page of your book, do it like a cross and trouble spread, and you can start to add more and more information from this. And this can be the basis for maybe your activity that your teacher is going to be setting you over the next week. Now, I want you to write that fact linked to each of these resources. Okay, so we've got biofuels. I like to start with biofuels because not everybody is aware of what they really are. Biofuels is anything to do with biology, living things. So anything that's grown and then used to generate electricity is a biofuel. Now most of the time that's just growing a tree, chopping it down and burning the wood. Okay, a lot of biofuels would be that kind of basis. But you could also grow some kind of crop and convert it into alcohols and then burn the alcohols. But anything that's living currently that we then use to generate electricity is a biofuel. Okay, they're different from fossil fuels that used to be living as well, but millions of years ago. Then we've got wind, so we get transfer kinetic energy in the wind. We drive a turbine inside the wind generator, which is connected to a generator. That generator changes that, transfers that kinetic energy into electrical energy. We've got hydroelectricity, where we've got some kind of dam, and we have water stored at a high level. It's got lots of gravitational potential energy. It's allowed to flow through some tubes, which transfers it to kinetic energy. That kinetic energy drives a turbine, which generates electricity. We've also got geothermal energy, so this can be placed in areas where the crust of the earth is relatively thin and you have easy access to hot rocks. Water is drilled, pushed down into a hole in the ground, heats it up, turns it into steam. That steam is used to drive a turbine, which is then connected to a generator, which transfers that kinetic energy into electrical energy. I'm going to be saying that a lot, by the way. Tides, there's lots of different ways you can access the water stored in tides, but the general principle is quite similar to hydroelectricity, that when you have a high tide, the water has a higher gravitational potential energy. When it's at low tide, it flows in the opposite direction, so we're using that process of that shifting of water to generate electricity. The sun, we can use two ways of getting energy from the sun. When we're generating electricity, we use PV, photovoltaic cells, like I said before. We can also use solar panels. There's a difference between those two things. PV cells, photovoltaic cells, they transfer sunlight directly into electricity. Solar panels, they take the heat from the sun and they heat up water. So you might have solar panels on the top of a roof. They'll have a store of water inside them. In the morning, the sun goes down on top of that water, heats the water up, and you can then directly put that water into your hot water tank. Okay, that doesn't generate electricity. That is another way you can get energy from the sun. We've got waterways, you've got the kinetic energy inside that moving water. There's lots of different ways you can access that, and you transfer that kinetic energy into electrical energy. And fossil fuels, the big one that we use at the moment, where we've got these ancient living things, so plants or animals that have decayed and decomposed and carbonized, and we burn it. And we burn it, we generate steam. That steam has kinetic energy. That kinetic energy in the steam is transferred to a turbine, which spins. That turbine spins a generator, which transfers that kinetic energy into electrical energy. Okay, these are the different resources that you need to know about. Okay, now I've got all that information in this table, where we've got the energy resources, names, and notice how I've linked the fossil fuels together, oil, coal and gas. Okay, because the information about those is the same. We've got the type of energy store. Okay, so in wind, the energy is stored in the kinetic energy of the particles that are moving in the wind. We've got whether it's renewable or non-renewable. We've got the uses, so whether it's just used for electricity generation or used for heating or used in transport. We've also got the type of power output. So fossil fuels have a high power output. Wind has a relatively low power output. You need a lot of wind turbines to make up one fossil fuel power plant. Okay, the amount of energy given out per second in fossil fuels is high. And we've got impact on the environment. So fossil fuels release carbon dioxide. It's linked to global warming. Okay, you need to know this table. You need to know the information on here. Okay, so a good use of your time would be to add this to the start of your energy resources picture and idea in the slide behind. This is the live National Grid status at 11 PM on the 9th of April 2020. That's when I've recorded this video. Okay, this is what currently the National Grid is doing. Okay, and we've got the demand. At the moment, we've got 30 gigawatts of demand. That's how much electricity the country is using and getting from the National Grid right now. Okay, and it is changing. The different proportions of these different things are changing. Each of these colours refers to a different type of energy resource. So the red are fossil fuels, the green is renewable, and the blue are other sources. Okay, and then these are broken down further into different types. So at the moment, the biggest proportion of energy generation in the UK is from fossil fuels. It's 35.3%. And the biggest proportion of that is from gas. And there's two types of gas. There's gas combined cycle. Okay, and that means that you burn the gas, which causes it to get lots of kinetic energy. That drives a turbine. But you also use the excess heat from burning that gas to produce steam to drive a second turbine. It's much more efficient than just using gas to drive a turbine on its own, which is what the open gas cycle is. We've got other types of energy. So we've got this pumped storage. That's where in the mountains, there's lots of them in Wales, I believe, where you pump up water at the top of a mountain and you store it until energy is needed at high demand. So normally this is quite low unless we've got a high demand time. We've got nuclear and biomass. We've got interconnectors, so 10% at the moment. Either we give electricity to other countries, to France, I believe to the Netherlands, to the Republic of Ireland, or the other way around, that they give us electricity, just to flatten out the demand, because demand changes throughout the day, which you're going to see in a moment. Okay, so here we've got some graphs. I love a graph. Okay, so this is the past day, so the half-hourly averages. So at the moment, okay, we're at just at 30 gigawatts. Okay, and it's broken down the demand into fossil fuels, renewable energy resources, how we're meeting that demand. And you notice that it changes throughout the day. So you think about, why is there a big dip here? What might be happening that we have such a low demand? We've gone from 30 to 20. What's happening there, you wonder? People are abed. We don't use as much electricity when we're asleep. Okay, throughout the day, the industry will be using electricity. People will be making cups of tea. Lots of different ways we can use the energy. Much less demand at night time. And the power companies and the National Grid, which is going to come up in future lessons, will make this as flat as possible. Makes it more efficient. And we've got the monthly average. We've got the past year. So notice, think about, okay, so why is there so much energy used around here? What's happening in these kind of areas? Why is the demand so low now? And then we've got all-time quarterly averages. So this is since 2013, how much electricity is demanded in the country. And it's got a big downward trend. Okay, but it's got these bumps. It goes up and down, up and down, up and down, up and down. Okay, think about why it's got such a big demand here in January, but a low demand here in July. What's the difference? Okay, hope everyone is doing very well today. Take care of each other. Bye bye.